Hi everyone, in this video we're going to be doing A-Level Further Maths 9231 Paper 13 Further Pure Maths 1 May June 2025 paper this paper is 2 hours long, so we'll try to finish within that time limit. So without further ado, let's get started. Okay, so for the first question, we're told that the matrix M represents the sequence of two transformations in the xy plane given by a stretch parallel to the x-axis scale factor 14, followed by a rotation anti-clockwise about the origin through angle pi over 3. And so for the first part, we're told to show that 2m is equal to this matrix. Okay, first of all, in order to do this question, we're going to have to first form the matrix M. So in order to do that, we need to know our matrices for our 2D transformations. So let's make space for them. So the way we do this is the first transformation goes in the right matrix, followed by the second transformation, and then these two matrices we multiply them together to get our matrix that represents these two transformations. Okay, so our first transformation is a stretch parallel to the x-axis with scale factor 14. So the general form would be this x 1 0 0 for this transformation, where x is the scale factor. So hence the first matrix, or the right hand side matrix, would be 14 0 0 1. And a good way to remember this is that this is the identity matrix, which doesn't show any stretch parallel to the x or y axis. So whenever you multiply any matrix with the identity matrix, the matrix stays the same. Okay, and this one would be your x and this one would be your y. So this is one way to remember your stretch matrix. Okay, now moving on to the second transformation. It's a anti-clockwise rotation about the origin through angle pi over 3. So for any anti-clockwise rotation about the origin, the general matrix is cosine theta minus sine theta, sine theta, sine theta, cosine theta. Yeah, so this is the matrix that you have. So unfortunately, I can't provide any tips on how to remember this. So if you have any tips, you can leave them down in the comments below. All right, so anyway, so this would be cosine pi over 3 minus sine pi over 3 sine pi over 3 cosine pi over 3. Okay, now let's simplify these matrices. Cosine pi over 3, that's half. And then minus sine pi over 3, that's minus square root 3 over 2. Sine pi over 3, square root 3 over 2, and cosine pi over 3 is half. And this is 14 0 0 1. So with that, we can start to evaluate our matrix M. So in order to do that, we're gonna have to get our element in the top left-hand corner. So to do that, it's in the first row, first column. So we multiply by the elements in the first row for the first matrix, and the first column in the second matrix. So this would just be half times 14 plus minus 3 over 2 times 0. So this would give us 7. Okay, now to get the next element, the one on the top right-hand corner, Since it's in the first row and second column of our new matrix, we're going to multiply the row by the first row in the first matrix and the second column in the second matrix. So basically, we multiply by half times 0 and then add minus 3 over 2 times 1. So this would just be minus 3 over 2. So this is our second element. Now let's head on to our bottom left element. Oh, sorry, this is supposed to be half. Okay, so for the bottom left element, it's in the bottom row and first column. So multiply by the bottom row of the first matrix and then the first column of the second matrix. So this would just be square root 3 over 2 times 14 plus half times 0. So that would just give you 7 square root 3. Okay, and then for the final element, just multiply by the second row and the second column of the second matrix. So this would just give you half. So square root 3 times 0 plus half times 1. So this is our matrix M. Now we can evaluate 2M. So to do that, just multiply the whole matrix by M. And to multiply a matrix by a constant, you just multiply each element in the matrix by that constant. So 7 times 2, that's 14, minus square root 3 over 2 times 2, that's minus square root 3. And 7 square root 3 times 2, that's 14 square root 3. And finally, this will just be 1. So it matches the answer that we're supposed to get, as you can see. So we can write shown. And this would be our final answer for this question, for this part. Let's head on to the next part. Okay, so here we're going to have to find the equations of the invariant lines through the origin of the transformation in the xy plane represented by M. Okay, so to do this question, we're gonna have to know what an invariant line is. So an invariant line is a line that doesn't like change at all after a certain transformation has been applied. Okay, so it's like an invariant point. Like it's a point that doesn't change when you apply a certain transformation. So to find that out, we're gonna have to multiply our M, just 7 minus square root 3 over 2 times 7 square root 3 half with our x, y, where x and y is a point along our invariant line. And this would be equal to big X, big Y. Okay? So big X, big Y is the new point, which is basically just the same as the old point. But here we're not interested in the point. We're interested in the line through the origin. So y would be equals to mx, and big Y would also be equals to m times big X. So we're now also going to substitute those into the equation. This would make it easier for us to solve our equations later on. Okay. Now we're going to evaluate the left-hand side of this equation by multiplying these two matrices. So let's do that. So to multiply matrices, first notice the number of rows and columns each matrix has. So the one on the left, the first one, has 2 rows and 2 columns. And then the second one, mx, has 2 rows and 1 column. And see if like the number of columns of the first row equals the number of rows on the second matrix. So these match. So we can multiply them. All right. And so this would be the dimensions of our new matrix that we're going to find out by multiplying them. It's going to be a 2 by 1 matrix, so 2 rows and 1 column. So let's make space for that. Equals to xmx. Okay, now we can start multiplying them. So to get the first row, it's in the first row, first column. So you multiply by the first row, first column. So that's 7x plus minus square root 3 over 2 mx. So minus square root 3 over 2 mx. And then for the second row, is in the second row, first column. So multiply 7 square root 3x plus half mx. Okay, so that's that. All right. Now let's convert this into a fraction. Okay, so our numerator would be the top element, and our denominator would be the bottom element. So we would get 7x minus square root 3 over 2 mx over 7 square root 3x plus half mx equals to x over mx. So first thing we realize is that we can cancel off the big x's. So this is just 1 over m. And we can also cancel off x. And we can factor out x from both the numerator and the denominator from the left-hand side. And to make it simpler, we can also multiply both the numerator and the denominator by 2. So let's do those at the same time. So this is going to be 14 minus square root 3m over 14 square root 3 plus m equals to 1 over m. And now we're ready to solve for m and find the equations. So to solve it, just cross multiply. So m times 14 minus square root 3m equals to 1 times 14 square root 3 plus m. So let's simplify everything. We get 14m minus square root 3m squared equals to 14 square root 3 plus m. Let's move everything to the right-hand side. We'll get, get square root 3m squared plus m minus 14m plus 14 square root 3 equals to 0. And this would be square root 3m squared minus 14m plus m, that's minus 13m plus 14 square root 3 equals to 0. So this is the final equation that we obtained, and this is a quadratic equation, so we can use the quadratic formula to solve it. So m would be minus b. B is minus 13, so minus 13, that's 13, plus minus square root of b squared, which is minus 13 squared, so that's 169, minus 4a, which is square root 3, c, which is 14 square root 3, over 2a, which is 2 square root 3. Okay, so let's evaluate this because okay, so you can type 169 minus 4 times square root 3 times 14 square root 3 into your calculator. You'll get 1. So you can just write this as 1 over 2 square root 3. Okay, so we'll get two answers for m. One is 13 plus 1 over square root over 2 square root 3. So that's just 14 over 2 square root 3, which you can simplify to be 7 over square root 3. And if you want to rationalize the denominator, you'll get 7 over 3 square root 3. And in the second answer, you'll get 13 minus 1 is 12 over 2 square root 3. So this would just be 6 square root 3. Then denominator, when you rationalize it, you'll get 6 over 3 square root 3, which is just 2 square root 3. Hence, our two answers is y equals to mx, which is y equals to 7 over 3 square root 3x and y equals to 2 square root 3x. So these are our final answers for this part. Let's head on to the next part. Okay, so for this part, we're told that the unit square S in the xy plane is transformed by M onto the rectangle P. Okay, so what they're telling is S has been transformed by M into the rectangle P. And then for this part, we have to find the matrix which transforms P onto S. Okay, so for this, you have to know that if like a certain shape gets transformed by matrix M into another shape P, to transform back into the original shape. So from P to S, you're gonna have to transform it using the matrix M inverse. So basically, we're gonna have to find M inverse, the inverse of M. So to do that, you're going to have to find the determinant. Okay, so 1 over the determinant of M, and then you multiply it by this new matrix. So if you have matrix A, B, C, D, you're going to have to change it such that you swap the A and D, so this becomes D and A, and you multiply B and C with -1. So it'll become like this. So for M is 7, and so A and D in our case will be 7 and half. Okay, so we're gonna have to swap those, half and 7, and then for B and C, that is square root minus square root 3 over 2 and 7 square root 3. So we're gonna have to multiply both those by -1. So this is square root 3 over 2 and minus 7 square root 3. Okay. Okay, this looks like one number. I'm gonna just, okay, there we go. And then to find the determinant, okay, so taking our example of our general form, A, B, C, D, the determinant is just AD minus BC. So AD minus BC. So our AD is just 7 times half, so that's 7 over 2, and minus BC. So BC would just be minus 3 over 2 times 7 over 3. So type it into your calculator. It's minus, right? Yeah, minus square root of 3. Okay. Yeah, be careful with this question. Always check back to your original. Minus square root 7 over 3. You would get minus 21 over 2. So plus 21 over 2 times this matrix. Okay, so just evaluate the constant. So it's 1 over 14 times half square root 3 minus 7 over 3 times 7. You can leave your answer as this if you want, or you can multiply everything by this, but personally, I prefer to leave it like this. So this would be our final answer for this part. Let's head on to the next question. Okay, so for this question, we're gonna have to prove by mathematical induction that this expression is divisible by 46 for all positive integers n. So this is proved by induction for divisibility. So in order to do this, just like any other proof by induction, you're gonna have to prove that this is true for n equals to 1. So first we'll let n equals to 1. So this is just 2025 plus 47 minus 2. So that's, type it into a calculator, 2070, and factor out 46, you get 45. So you got a whole number when you divide it by 46, so you can say hence true for n equals to 1. Okay. And now you're gonna have to assume that 2025 to the power of k plus 47 to the power of k minus 2 is divisible by 46, where k is a positive integer. Okay? Okay, now this is where the main part begins. We're now gonna let n equals to k plus 1. Okay? So this would be 2025 k plus 1 plus 47 k plus 1 minus 2. Okay, so this is where the process gets slightly different. So for divisibility, you're gonna have to find the difference for where for the case where n equals to k plus 1 and the case where n equals to k, or you can find the sum of it, because okay, let's do a simple example. So you want to prove that 6 is divisible by 2, and you know that 2 is divisible by 2. Okay, so all right, using that, you can add 6 with I don't know, 8, right? Like if they're divisible by each other, you'll get 14, and then you can factor out 2, and then you can say that hence 6 is divisible, or you can find the difference between them, 8 minus 6, you'll get 2, the divisor itself. So you can also say that, you know, 6 is divisible by 2. So this is the same type of logic that we're trying to use in here. Okay? So now we're going to find the sum of it, since I think it's going to be easier to do it that way. We can also find the difference if we want. Okay. Or should we do the difference? Okay, let's do the difference, okay? Because if you do the difference, the minus 2's, they will cancel out. Yep, they will. All right. So let's find the difference between these two terms. So first, group all the like terms together. So 2025 k plus 1 minus 2025 to the power of k plus 47 k plus 1 minus 47k minus 2 minus negative 2. That would just be 0. Okay? All right, now we're going to split this up using our laws of indices. So this is just 2025 to the power of k times 2025 to the power of 1. So just times 2025 minus 2025 to the power of k. So we'll do the same for 47 to the power of k plus 1. So that's just 47k times 47 to the power of 1 minus 47k. So if you can see, for these two sets, we can actually factor out 25K. So this becomes 2025 minus 1 and 47K. So this becomes 47 minus 1. Now simplifying further, we'll get 2025K times 2024 plus 47 to the power of K times 46. Okay, now let's try to factor out 46 from this whole expression. So 46, so you would get, let's see if 2024 is divisible by 46. Yep, you would get 44. So 46 times 2025 to the power of K times 44 plus 47K times 1, or just 47K. So hence, you can explain your reasoning in here. So I'm going to use the reasoning that I gave you guys just now. So you can say since the difference between the terms for which n equals to k plus 1 and n equals to k is a factor of 46 and the term for which n equals to k is also a factor of 46. The term for which n equals to k plus 1 must be divisible by 46. So n equals k plus 1 is true. And hence you can write your final statement that hence by principle of mathematical induction, the above statement is true. This would be our final answer for this question. Let's head on to the next question. Okay, so for this question, we are told that this quartic equation has roots alpha, beta, gamma, and sigma. And for the first part, we're going to have to find the value of the alpha squared plus beta squared plus gamma squared plus sigma squared. So basically the sum of the squares of roots, okay? So in order to do this, okay, there's a formula for this that we can apply. So we're going to represent the sum of all this using sigma alpha squared. Okay, so the sum of the squares of the roots. And this is equal to the sigma alpha whole thing squared. So sigma alpha is basically the summation of alpha, beta, gamma, and sigma. So basically the sum of your roots, okay? And then this would be minus 2 times sigma alpha beta. So this is the sum of your root pairs. Okay, so your alpha beta times alpha gamma plus alpha sigma plus beta gamma plus beta sigma plus sigma gamma. So this whole thing is represented by sigma alpha beta. Okay, so to use this, we know that this formula for the sum of our roots is minus b over a squared, where a is the coefficient of x to the power of 4, and b is the coefficient of x cubed. And then for sigma alpha beta, that is basically c over a, where c is the coefficient of x squared, and then a is still the coefficient of x to the power 4. Okay, so this is minus 0 over 1 squared minus 2 times 7 over 1. So this would just be minus 14. So this would be our final answer for this question. Let's head on to the next part. Okay, so to do this part, we're gonna have to find the value of alpha to the power 4 plus beta to the power 4 plus gamma to the power 4 plus sigma to the power 4. So basically the sum of the roots to the power 4. Okay, so first of all, we're gonna have to define like a notation. So we'll let alpha to the power of n plus beta to the power of n plus gamma to the power of n plus sigma to the power of n be Sn. Okay, so this therefore would just be S4, and our previous answer, the squares, would just be S2. So we're going to substitute this into our original quartic equation. So x to the power 4 will be S4, then plus x squared would similarly be 7S2, and then x would just be S1, so plus 3S1, and then plus 22 S0 all equals to 0. Okay, now this would be S4 plus 7 S2, which is, we found in our previous part, minus 14, plus 3 S1. S1 is just alpha plus beta plus gamma plus sigma. So that's just the sum of our roots, which is minus b over a. We found in our previous part, that's just 0. And then S0 would just be 4, because if you substitute n equals to 0, anything to the power 0 would just be 1, so this would just be 1 plus 1 plus 1 plus 1, which is 4, all equals to 0. So type it into your calculator, we'll get S4 minus 10. Okay, let me check if I did it correctly. Minus 98 plus 0 plus 88. Yep, minus 10 equals to 0. And hence S4 would just be equals to 10. So this would be our final answer for this part. Let's head on to the next part. Okay, so now we're gonna have to use standard results from our list of formula, our MF19, to find the value of this whole expression. Okay, so first of all, we're gonna have to simplify this expression in our bracket, okay? So let's write down this entire expression in our bracket. So this, to simplify this, we're just going to use our a plus b squared formula, which is a squared plus 2ab plus b squared, okay? So I'm just going to keep it up here for reference. So the first one, alpha squared plus r to the power of 2, would just be alpha squared, which is alpha to the power of 4, times 2 alpha squared r plus r squared. And then for beta squared plus r, it would just be beta squared, which is beta to the power of 4, plus 2 beta squared r plus r squared. And this will be plus gamma squared, which is gamma to the power 4, plus 2 gamma square r plus r squared. And then finally, we have sigma squared, which is sigma to the power 4 plus 2 sigma squared r plus r squared. Okay, so let's group all the terms with the same power. So alpha to the power 4 plus beta to the power 4 plus gamma to the power 4 plus sigma to the power 4. Okay. And then let's group all the 2 alpha squares and all that. So 2 alpha square r plus 2 beta square r plus 2 gamma square r plus 2 sigma square r plus r squared plus r squared plus r squared plus r squared. So that's just 4r squared. So this first part, we already found it in our previous part here. So I can just write 10. And then for this whole expression, we can see we have a common factor of 2r. So we can factorize 2r times alpha squared plus beta squared plus gamma squared plus sigma squared plus 4r squared. This would be equal to 4r squared plus 2r times, we also found that in our previous part, this is just minus 14 plus 10. So this would be 4r squared minus 28r plus 10. So this is our whole expression simplified. Now we can substitute into the summation formula. So this is from r equals to 1 all the way to 10. So 4r squared minus 28r plus 10. So as you can see, our question explicitly told us to use our standard results from our MF19 to find the value. So in order to do this, we're going to have to split up the terms into separate summations. So just like when you're integrating like a sum or a difference, you're going to have to split it up like that. So this would be summation of 4r squared plus the summation of minus 28r plus the summation of 10. And just like when you're integrating or differentiating, you have to take out any constant terms that you have. So we'll take out 4 in here. So r squared minus 28 sigma r1 10 r. And then this one, this is a constant term. So for any constant terms, you're going to have to substitute. You're going to have to multiply this term inside. It's 10 times the upper limit of the summation. So 10. So 10 times 10, that's just 100. Okay. Now we can use our formula to find this. So for r squared, we have this formula for r equals to 1 all the way to n. So 1/6 n plus times n plus 1 times 2n plus 1. So I'll give you some time to see it. Okay. Now this, let's substitute it. So 1/6n times n, which is 10 times n plus 1, which is 10 plus 1 times 2n plus 1, which is 2 times 10, 20 plus 1, which is 21. Let me check. All right, that's the correct formula. And then for the summation of R, this is just half n times n plus 1. Okay, so this is half times 10 plus 10 plus 1, which is 11 plus 100. So type all this into your calculator. So you will get the final answer of 100. Okay, let me see if I substituted everything correctly. Okay, so this would be our final answer for this question. Let's head on to the next question. Okay, so for this question, we're told to let W subscript, we're told to let W subscript R be equals to R times R plus 1 times R plus 2 all the way to R plus 9. And for the first part, we have to show that this result is true for W subscript R plus 1 minus W subscript R. So in order to do this, let's write down the equation on the left-hand side. Okay, and then WR plus 1, let's use this as a reference. So WR plus 1, our first term would obviously be R plus 1, followed by R plus 1 plus 1, which is R plus 2, and then followed by R plus 3, all the way to R plus 9 plus 1, which is R plus 10. And then minus WR, we know that's just the original expression that they gave us, all the way to R9. Okay, now we're gonna have to figure out which common factors that they have that we'll be able to factor out. Okay, so for W, R plus 1, we can factor out R plus 1, R plus 2, all the way to R plus 9, everything excluding R plus 10. And for W, R, we can factorize everything from R plus 1 all the way to R plus 9. So let's factor that out. R plus 1 times R plus 2 times R plus 9, and then bracket R plus 10 minus R. So R plus 10 minus R, that is just 10. So 10 times R plus 1 times R plus 2 all the way to R plus 9, which is exactly the same as our right-hand side. So we can write shown. So this is our final answer for this part. Let's head on to the next part. Okay, now they told us that UR is equals to this. You have to find the summation of UR from R equals to 1 all the way to N in terms of N. Okay, so first of all, we should try to express UR in terms of this result that we obtained from the previous part. So we can see that UR is very similar to our result that we obtained from the previous part. It's just our previous part result divided by 10. So we can write that UR is just 1 over 10 of WR plus 1 minus WR. Yep, okay. And now we can substitute that into the formula, the summation formula. 1 over 10 times WR plus 1 minus WR. So the reason we did this is because by having a difference, we can use our method of differences to easily evaluate this answer. So let's take out any constant terms. So let's take out 1 over 10. And now we just have WR plus 1 minus WR. So let's start. So first let's substitute R equals to 1. So this would be W2 minus W1. And then R equals to 2. That's W3 minus W2. And then R equals to 3. That is W4 minus W3. Okay, and now we're going to find the last two sets of terms. So we're going to substitute R equals to N minus 1 and R equals to N. So this would then be Wn minus 1 plus N. That's Wn minus Wn minus 1 plus R equals to N, which is the last term. So that's Wn plus 1 minus Wn. Okay, now let's look for the terms that we can cancel out. So right off the bat, we can see we can cancel W2 and also W3. And hence we should also be able to cancel out W4 because W4 would be WR when R equals to 4 in the next set of terms. So only W1 would remain in here. And for our second set of terms, we can see we can cancel Wn. And hence we can cancel out Wn minus 1 because Wn minus 1, it would also appear in WR plus 1 when R equals to N minus 2 in the previous set. So this is why it cancels out. So our final answer would just be 1 over 10 times Wn plus 1 minus W1. Okay, now let's expand this out a bit. So 1 over 10 Wn plus 1 minus 1 over 10 W1. So let's write Wn plus 1 in terms of this notation that we have. So let's substitute R equals to N plus 1. So this would just start from N plus 1 times N plus 2. Okay, so N plus 1, N plus 2, all the way to N plus 10. And then for W1, it would just be 1 times 2 times 3, all the way to 1 plus 9, which is 10. So this is basically 10 factorial. Okay, we can further simplify this. Okay, so N plus 10. And we know 10 factorial divided by 10 factorial will just give you 9 factorial. So this is our final answer for this part. Let's head on to the next part. Okay, so for this part, we're given that V subscript R is equals to X sub of WR plus 1 minus X sub of WR. We have to find the set of values of X for which this infinite series V1, V2, V3 all the way to V infinity is convergent. And we have to give the sum to infinity when this exists. Okay. All right. So first of all, let's evaluate V1 plus V2 plus V3 all the way to Vn. All right. So you can write this as X W2 minus XW1 plus XW3 minus XW2 plus XW4 minus XW3 all the way to XWN plus 1 minus XWN. So if you realize, this actually looks very similar to our method of differences that we did in the previous part. So we'll just cancel the terms in the similar manner. So everything cancels out except wn plus 1 and w1. So everything will cancel out. Okay. Yeah. So this is our general form. xwn plus 1 minus xw1. And we can further simplify this w1 to 10 factorial. Okay. And then now we can figure out what is the set of values of x for which this will be convergent. So basically what they mean by convergent is as like n approaches infinity, will this whole expression approach a finite value or not? So in order to make sure that happens, our x can either be 1 or -1, or it can be between 1 and -1. So basically like a proper fraction. Okay, so first let's write down, okay, for x equals to plus or minus 1. So 1 to the power of anything is just 1. So 1 minus 1 would just be 0. So sum to infinity would be 0. Same for -1, because -1 to the power of 10 factorial, since it's an even number, it will just be 1. And then for x, -1 to the power of wn plus 1, you can assume that it's even. So again, this would just be 1 minus 1. Okay. All right. Now let's take our second set of values. For x is between -1 and 1, basically a proper fraction. So when that happens, our x, it would be something like 1 over x to the power of wn plus 1. And as the n approaches infinity, this will also like get bigger and bigger. So this would like just approach a 0. So 0 minus x to the power of 10 factorial, the sum to infinity would just be minus x to the power of 10 factorial. So here, we're just going to write sum to infinity would be minus x to the power of 10 factorial. So this would be our final answers for this question. Let's head on to the next question. Okay, so for this question, we're told that the plane pi has this vector equation. Okay, so this is a position vector of a point on the plane, and this is a direction vector of a line on the plane, and so is this one. And then for the first part, we have to find the Cartesian equation of pi, giving our answer in this form. Okay. Okay, so first of all, we're going to have to find the normal vector to the plane, which we can find out by finding the common perpendicular to any two direction vectors on the plane. So we're already given two direction vectors, which is this and this. So we just have to find the common perpendicular between them, which we can do by finding the vector product. Okay, so I, J, K. So the first vector is 1, -2, -1, and then next one is 3i, so 3, 2, and -2. Okay, and then to find this, multiply by the I first. So to get this, you cover these two rows, both of which contain the I, and you find the determinant of like this row. So determinant of this is just -2 times -2. That's 4 minus -1 times 2, which is -2. So 4 minus -2, that is 6. And then minus j. To find that, oh my, what is this? Okay, me erase this, okay? To do that, similarly, you will cover both rows that contain j, and you'll get the determinant of 1, -1, 3, and -2. So just cross multiply. So 1 minus -2, that's -2, minus -1 times 3. So -2 minus -3. So that's just 1. And then finally for the k, all right, let me erase. All right, the k. So you just cover all the rows and columns with k and find the factorial. I mean, not the determinant of the remaining elements. So this is just 2 minus -6. So that would just be 8. Okay, now we can write our normal vector in column form. So this is 6 minus 1, 8. So this is our normal vector. And now, and then hence our equation would just be 6x minus y plus 8z equals to d. And to find this d, we just have to substitute a point, the coordinates of a point on the plane, which is given right here. So this is 2, 3, -2. So we'll just substitute that. So 6 times 2 minus 3 plus 8 times -2. So this is just 12 minus 3 minus 16, which is -7. Hence, this is our d. We can write that 6x minus y plus 8z equals to -7. So this would be our final answer, this final equation for this part. Let's head on to the next part. Okay, so for this part, we're told that the point P has this position vector 4, 2, 9, like that's the coordinates of P. And we're going to have to find the position vector of the foot of the perpendicular from P to pi. Okay, so to do this, let's do a sketch. So this would be like the sketch of the side view, okay? So this would be our plane pi, and this is our point P. And the direction vector of the perpendicular will be the normal vector to the plane pi. So this would just be 6 minus 1, 8. And we're going to have to find the position vector of this line meeting the plane. So in order to do that, let's form a vector equation of this line starting from P. So just take the position vector of P and the direction vector of the perpendicular. So plus mu times the direction vector of the normal equals to x, y, z, where x, y, z, they are the coordinates of the foot of the perpendicular. So let's label this as x, y, z. Okay, now let's expand this left-hand side equation. So x, y, z will be equal to 6 mu times 6 is 6 mu plus 4. And 2 plus mu times -1, so 2 minus mu and 8 mu plus 9. So we can just equate each component to the x, y, and z. So x would be 6 mu plus 4, y would be 2 minus mu, and z would be 8 mu plus 9. So we're going to substitute these into the equation of the plane. So this would be 6 times x, which is 6 mu plus 4 minus y, which is minus 2 minus mu, plus 8z, which is 8 times 8 mu plus 9 equals to negative 7. Okay, so now let's expand everything out. So 6 times 6 mu, that's 36 mu. And 6 times 4, that's 24. Minus 2 minus mu, that's plus mu. Plus 8 times 8 mu, that's 64 mu. Plus 8 times 9, that's 72, equals to negative 7. So let's keep all the terms in terms of mu on the left-hand side. So that's 36 mu plus 64 mu, that's 101 mu. And this would just be minus 7, minus 72, plus 2, minus 24. It's minus 101. And hence, we can easily figure out that mu is just minus 1. Okay, now let's substitute our mu back into here, our xyz. So 6 mu plus 4 is just minus 6 plus 4, which is minus 2. And then 2 minus mu, that's 2 minus negative 1, which is 3. And then 8 mu plus 9, that's 8 negative 1. That's minus 8 plus 9, which is 1. And hence, the foot of the perpendicular is just minus 2, 3, 1. And just to be safe, we're going to write it in IJK format as well. So minus 2i plus 3j plus k. So this is our final answer for this part. Let's head on to the last part. Okay, so for this final part, we're told that the line L is parallel to this vector. So we can consider this to be the direction vector of line L. Okay, and now we have to find the acute angle between L and pi. Okay, so again, let's draw a diagram, like a side view of it. So we'll let this be our plane pi, and we'll let this be L. Okay, so this is obviously the normal vector to the plane, and we're interested in finding this angle. Okay, and to find this angle, we are going to have to find this angle first, which I'll call 90 minus theta. Okay, or like, yeah, so if we get an acute angle, we're gonna do this. Okay, so yeah, but we can also get like an obtuse angle. So like this, when we take the dot product between the normal vector and L. So this would just be 90 plus theta. Okay, so let's take let's take the scalar product. So let's write down the formula. So this is n dot L equals to n, okay, modulus of n times modulus of L times cosine 90 degrees minus theta. Okay, so to do this, let's substitute n dot l. So n dot l n would just be 6 minus 1, 8. 6 minus 1, 8 dot with l, which is 3, 5 minus 1. So 6 times 3, that's 18. Minus 1 times 5, that's 5. And 8 minus 1, that is 8. So this would be 5. And then and modulus of n times modulus of l just be 6 squared, which is 36, plus negative 1 squared, which is 1, plus 8 squared, which is 64, times 3 squared, which is 9, plus 5 squared, which is 25, plus negative 1 squared, which is 1. So this is 36 plus 64 plus 1, squared 101, and then 9 plus 25 plus 1, that's 35. So 101 times 35, this is square root 353. Okay, so hence, let's substitute these back into the original equation. Okay, so this is cosine 90 minus theta. Okay, so this one would be equal to 5 over square root 3535. So as you can see, our value for the cosine of 90 degrees minus theta is positive. So this suggests that 90 degrees minus theta is an acute angle. So hence we can eliminate this and use this diagram to find theta. Okay, so let's use our complementary angle identity here. So let this be theta and this 90 minus theta. This is A, B, C. So cosine 90 minus theta and here is equal to C over A. And what else is equal to C over A? It's also equal to sine theta, C over A. So we can write this, as sine theta equals to 5 over square root 3535. And then theta would just be the sine inverse of 5 over square root 3535. So sine inverse by square root 3535. I'm gonna put it in degrees. Okay, so this would just be 4.8 degrees to 1 decimal place. So this would be our final answer for this part. Let's head on to the next question. Okay, so for this question, we're told that the curve C has this equation where A is a positive constant. And for the first part, we're going to have to find the equations of the asymptotes of C. Okay, so to do that, we can first equate the denominator of the y function to 0 to find a vertical asymptote. So x plus a equals to 0. You will get x minus a. So your vertical asymptote is equal to x minus a. Okay, let me put a semicolon in here. Okay, and now to find the other asymptote, let's look at the function here, the equation. So if you can see, the degree of the numerator is higher than the degree of the denominator. So this means that we will have an oblique asymptote. And to find the equation of the oblique asymptote, we should do long division for this, okay? So it's like how you're trying to, make this into like partial fractions. It's almost like that. So let's do that. So x squared plus 0x plus a plus x plus a. Okay, so this one is minus x squared plus ax. So you have to put x in here. This is minus ax plus a, and this would be also minus ax. So to make it minus ax, you have to multiply by minus a. So minus a times plus a, that's minus a squared. And for this, the remainder would be a minus minus a squared, which is a squared plus a. So hence, y would be equal to x minus a plus a squared plus a over x plus a. And hence, this would be our oblique asymptote, and we can conclude that oblique asymptote is equal to y equals to x minus a. So these are our final answers for this question. Let's head on to the next part. Okay, so for this part, we're going to have to find, in terms of A, the x coordinates of the stationary points on C. Okay, so to do this, let's take our equation of the curve, this version, okay? Like this is much simpler to differentiate. So y equals to x minus a plus a squared over x plus a. And let's rewrite it as x minus a plus a squared plus a times x plus a to the power of -1. Okay, now we're ready to differentiate this. So first differentiate x, so that's just 1, and then minus the derivative of a, so that's 0, so 1. And then now, oh, sorry, yeah, and now we're going to differentiate times a squared plus a times x plus a to the power of -1. So to do that, you take out your constant term, which is a squared plus a, and you differentiate x plus a to the power of -1. So to do that, you bring your power to the front, so minus x plus a, and then you minus 1 from your original power, which is minus 2. And then now you differentiate the inner function with respect to x, so that's just 1. So you multiply by 1. Okay, so this would just be 1 plus a squared plus a over x plus a squared. Oh, there's a negative sign, so this should be 1 minus, okay? All right, and now I'm going to equate this to 0. So equating this to 0, get a squared plus a over x plus a squared equals to 1. Okay. And then you'll get x plus a squared equals to a squared plus a. And now we can take the square root on both sides. So you'll get x plus a equals to the positive square root of a squared plus a. And then you also get x plus a equals to the negative square root of a squared plus a. So x would be equal to a squared plus a minus a, and the other point would just be minus a squared plus a minus a. So this would be our final answers for this part. Let's head on to the next part. Okay, so for this question, we're going to have to sketch C, stating the coordinates of any intersection with the axes. So we're going to have to state the coordinates of the x and y intercepts. Okay, so first, let's draw our axes. So use the whole space provided. And now we're gonna draw our asymptotes. So we have x equals to negative a. So that's negative because a is positive. So this is, okay. This is x equals to negative a. And then this is y equals to x minus a. So this, just find your x and y coordinates. So the x and y intercepts. So the y-intercept for this oblique asymptote is just minus a. Okay, so minus a, it's right here. And our x-intercept, just make y equals to 0. So x would be equals to a. So x equals to a is right here. Okay, and now we can, wait, let me, all right, let me, okay, sorry. All right, this, never mind, this isn't too good. Off. Okay, you know what, let's just stick to this. Yeah. All right. So this is y equals to x minus a. All right. Now let's find our x and y intercepts for this curve. So x-intercepts, y-intercepts, just substitute 0 into the equation of the curve. So you'll just get a over a, which is 1. Okay, so 1 could be here. Okay, so you can write 0, 1. And then for x-intercepts, just equate y to 0. So you'll get x plus a equals to 0. And you'll get x squared equals to minus a, which is impossible because minus a is negative, but x squared can only be positive. So there are no x-intercepts in here. Okay. All right. Now let's put our x coordinates of the stationary points. All right. So this, wait. Okay. So this first one, this is definitely positive minus positive. So that would be positive. Okay. So that is going to be like here. Okay. So the first branch, oh, this is not, okay, let me, okay, never mind. This is not, okay, let me, okay, that's a good point. All right. So this would be our stationary point, okay? And then the second branch would be this with this stationary point. So this is actually negative, okay? If you don't realize it. So it'll be somewhere here. So let me just sketch this branch. Yep. So this is the stationary point, okay? All right, so this is our entire curve C, okay? With the coordinates of the intersection, the y-intercept. Don't forget to write your x and y. Okay, so let's head on to the next part. Okay, so here we're just gonna have to sketch the curve with the equation y equals to the modulus of x squared plus a plus x over x plus a. So this is just the modulus version of this curve that we sketched in here. And this curve, the whole function is under the modulus function, not just the x. So whatever is below the x-axis, you're going to have to reflect it above the x-axis. Okay? So let's do that. Okay? You don't have to draw the intersection points or the asymptotes, but if it helps you, no problem. So this is your x and y intercepts. Okay, let me draw it. Okay. All right. Yep, this is the upper branch, and then the lower branch is something like no, something like this. Okay, yeah. So this is our curve with this equation. All right, let's head on to next question in the next part. Okay, so here we're gonna have to find the set of values of A for which this equation has two real solutions. So let's write down this equation first. So if you realize the left side of this equation is the equation of our curve in here. And then A, well, A is, this is minus A. So okay, so let me see. All right, so this is a squared plus a, which is definitely more than a. The square root of it is more than a, and then minus a, this is more than a. So yeah, a, sorry. I think a should definitely be like above here. Okay, you know what? Let's substitute a into like 2 or something. Okay, so let a be 2. So 2 squared plus 2 equals to 6. So 6 squared 6, and then minus 2. Oh, you get a smaller value than a. Yeah, so yeah, that proves my point. Okay, so we can assume y equals to a to be here. Okay. All right, so now we're gonna have to find a set of values of a for which this will have two real solutions. Okay, so in order to have two real solutions, this line y equals to a must only be touching 2 points on this curve. So that means it cannot go beyond the minimum point here and the turning point in here. So it always has to be between these two turning points. Okay. Okay, how should we do this? A minute. Okay. Hmm. Okay. Firstly, um, yeah, so this is A. Okay, right. Hmm. Okay. Okay. All right. So let's first solve this equation without the modulus. Then we'll find the solutions for this branch in here above the x-axis in the original curve without the modulus. Okay. So this x squared plus a equals to ax plus a squared. Okay, so this would just be x squared minus ax plus a squared minus a equals to 0. Okay, so for this to have two real solutions, um, your b squared minus 4ac has to be equal to 0. Okay, so b squared is just minus a squared minus 4 times a, which is 1, and then c is a squared minus a squared goes to 0. So this is a squared minus 4a squared plus 4a equals to 0. Okay, so this is minus 4a squared plus a squared minus 3a squared plus 4a more than 0. Okay, let's get rid of the negative coefficient and flip the inequality sign. Okay, let's factorize a. This 3a minus 4 equal less than 0. So let's sketch the curve in terms of like the function of a. So this is less than 0. So this is going to be a equals to 0, and so b equals to 4 over 3. So hence, this is a is between 0 and 4 over 3. Okay. Now let's see if any of the values in here exceed the stationary point. Okay, so the stationary point we're looking for is a squared plus a sorry shoot so a squared. Oh my, this is tough. Okay. Mm, all right. For two solutions. So a hmm. All right. Should I take the negative branch? Let's see. Okay. Okay. Hmm. Okay. Sorry for the delay, everyone. So I realized my mistake in here. Okay. Yeah. Um. So we're supposed to like. Okay. So we're not actually supposed to consider the negative branch at all because if you see in our curve, if we consider that, then anything in the negative branch, there would be four solutions. So yeah, we cannot go into there. So we're only going to consider the positive branch, okay? All right, so this is x squared minus ax plus a minus a squared equals to 0. Okay, and now let's use our b squared minus 4ac more than 0. Okay, so we're only talking about this one, okay? This one, this positive section in the original curve above the x-axis, okay? So b squared is minus a squared, so a squared minus 4ac more than 0. Now let's form our equation. So minus 4 plus 4a squared equals to 0. So this is 5a squared minus 4a equals to more than 0. Okay, now let's take out the a. So this is a times 5a minus 4 more than 0. Okay, let's sketch the curve. Since the coefficient of x squared is positive, this would be a smiley shaped curve. And let's draw critical points. So a equals to 0 and 5 minus 4 equals to 0. So a is equals to 4 over 5. And then this would be more than 0. So hence we can only take values from here or here. So this would be a less than 0 or a more than 4 over 5. But we already know that a is a positive constant, so we have to reject this. And hence, the final answer is a more than 4 over 5. So this is our final answer for this question. Let's head on to the next question. Okay, so for this question, we're told that the curve C has this polar equation for the domain of theta between negative pi over 2 and pi over 2. So for the first part, we are going to have to find the polar coordinates of the point on C that is furthest from the pole, giving your answers correct to 3 decimal places. Okay, so first of all, to find the points furthest from the pole, we're going to have to find dr d theta and equate it to 0. So let's do that. So first, let's write down our polar equation. E to sine theta cosine theta. Now let's differentiate each side with respect to theta. So for the r squared, that would just be 2r. So differentiate with respect to r first and multiply by dr d theta. This is implicit differentiation. And for the left-hand side, we're going to use a product rule. So first, we're going to differentiate e to the sine theta. So that's just cosine theta times e to the power of sine theta times cosine theta. So this is just cosine squared theta times e to the power of sine theta. Sorry. And then this would be plus the derivative of cosine theta, which is minus sine theta, times e to the power of sine theta. So this is minus sine, oh my, minus sine theta times e to the power of sine, sorry, sine, oh my, pen is glitching, sine theta. Okay, so now we're gonna equate dr d theta to 0, and we would get, sorry, cosine squared theta times e to the power of sine theta minus sine theta e to the power of sine theta equals to 0. Okay, let's factor out e to the power of sine theta. Whoa. And then this is, oh my. Okay, sorry guys. Let me adjust my pen. Okay, so this is, oh my, made it worse. Sorry. So this is cosine squared. Whoa. Sine squared minus sine theta equals to 0. So we know that e to the power of anything isn't equal to 0, so we can just divide by e to the power of sine theta. So we'll get cosine squared theta minus sine theta, and let's also replace cosine theta with 1 minus sine squared theta minus sine, oh my, this is sine theta equals to 0. Okay, now let's simplify this quadratic equation. So sine, whoa, squared theta plus sine theta minus 1 equals to 0. Okay, so to solve this, we're going to use the quadratic formula. So sine theta, oh my, would be equal to minus b. So minus 1 plus minus b squared, which is 1 minus 4 times a times minus 1 over 2a, which is just 2. So this would give you sine theta equals to square root 5 minus 1 over 2, and sine theta would also be equal to minus square root 5 minus 1 over 2. So this value is positive, and this value is negative, and more than 0. So we're gonna reject this. Oh my goodness. Sorry, oh my gosh. Reject this thing. Okay, let me try to do it without hand resting. Okay, so we're gonna reject this, sorry. And let's find the value of theta. So that's just sine inverse square root 5 minus 1 over 2. That is equal to, don't forget to set your calculator to radian mode. That is 0.6663 SF. I'm sorry, 3 dp. Okay. All right. Okay, let's now find R. Okay. So R would just be the square root of e to the power of sine theta. So e to the power of square root 5 minus 1 over 2 times cosine theta. So cosine times sine inverse square root 5 minus 2 over 2. So this is equal to e to the power of, e to the power of square root 5 minus 2 over 2 times cosine this square root, that would be 1.20823 dp. Okay, so hence our final answer would just be in terms of r comma theta, so 1.208 comma 0.666. So this is our final answer for this question. Let's head on to the next part. Okay, so now we're gonna have to find the polar coordinates of the point on C that is furthest from the half line theta equals to pi over 2, giving your answer correct to 3 dp. Okay, so what do they mean by the half line theta equals to pi over 2? They just mean the y-axis basically. So this is, they call it theta pi over 2. So we want to find the point that is furthest away from our so-called y-axis, okay? So like the greatest x value. So hence we're gonna have to find our dx d theta and equate it to 0. So let's do that. So let's first find an expression of x in terms of theta. So, all right, you know what? Let's just find x squared since we only have r squared. So x squared, oh my, equals to uh, r squared cosine, goodness, cosine squared theta. Okay, uh, so x squared would just be, oh, sorry, e to the power of sine theta times cosine theta times cosine squared theta. So just cosine cubed theta. Okay, and now let's differentiate each side with respect to um, theta again. So this would just be 2x times dx d theta. And then the right-hand side, we're just gonna use a product rule. So first we'll differentiate cosine cubed, all right? So cosine cubed, that is just 3 cosine, oh my, cosine, I don't know why it's happening. Cosine, oh my gosh, sorry, times the derivative of cosine, which is minus sine, so minus sine theta times e to the power of sine theta, and then plus the derivative of e to the power of sine theta, that's cosine theta times e to the power of sine theta times cosine cube. So that's cosine, oh my god, cosine to the power of, oh my, power of 4 times e to the power of sine theta. Okay, so let's equate this to 0. We will get cosine to the power of 4 theta times e to the power of sine theta minus sine. Oh my gosh, my pen is glitching heavily. Okay, so this is 3 sine. Oh my gosh, 3 sine theta cosine. Oh my gosh, cosine squared theta e to the power of sine theta all equals to 0. 0. Okay, so we can factor out the cosine square. Okay, let's factor that out. So cosine square theta, oh my gosh, e to the power of sine theta, that is equal to cosine squared theta minus 3 sine theta. Okay, now let's divide by e to the power of sine theta. Okay, so we will have cosine, oh my goodness, cosine squared theta times cosine squared theta. Actually, this cosine squared theta. Oh my, what's going on? I can't erase. Okay, let's I gotta change it. Sorry. Let's change it to 1 minus sine squared theta minus 3 sine theta equals to 0. Okay, so let's equate both of these to 0. So cosine squared theta equals to 0. Just get cosine theta equals to 0, and this would get us, let's see whether it fits for cosine negative pi over 2. Okay, so this is theta equals to negative pi over 2 and pi over 2. And now let's equate this to 0. So at the same time, let's also simplify this a bit. So sine squared theta plus 3 sine theta minus 1 equals to 0. All right. So, okay, let's see if we should. Okay. Right, so this sine theta, substitute into quadratic formula. So minus b, that's minus 3, plus minus b squared, that's 9 minus 4 times a c over 2a, which is just 1. So this would give you sine theta equals to 9 plus 4, which is square root 13. So square root 13 minus 3 over 2. The second value would be sine theta equals to minus 3 minus square root 13 over 2. So let's see if we can reject any value. We can reject this one because this is less than a negative 1, so reject. And then so now we can only accept this. So let's find the value of theta for this. Okay, sine inverse square root 13 minus 3 over 2. Okay, so we got 3 decimal places. That is 0.308, 3 dp. And then the r value is just the square root of e sine theta, square root 13 minus 3 over 2, cosine theta. So cosine 0.308. Okay, so just type it into your calculator. So this is 1.136 to 3 dp. And for this one, it's just going to be r square root of e sine pi over 2 cosine pi over 2. So cosine pi over 2 is 0. So this is just going to be 0. So it's basically at the pole. So hence our final answers are r slash theta. So 1.136, comma 0.308 and 0, pi over 2, and lastly 0, negative pi over 2. So these three are our final answers. Oh wait, sorry, this is we're supposed to reject this. Yeah. So yeah, because it's like on the pole, so it's obviously not the furthest. So yeah, we only have one final answer, okay, which is this. So without further ado, let's head on to the next part. Okay, so to do this question, okay, so this question, we have to sketch C. So to do this question, draw your initial line first. Okay, theta equals to 0. And substitute your values for, substitute your respective values for theta within your domain, which is between pi over 2 and negative pi over 2. So as we know, for both pi over 2 and negative pi over 2, r is equals to 0. So our graph will like end on the pole, all right? Okay, so first, let's substitute theta equals to 0. So you get like 1, okay? So you get 1, theta equals to 0, and let's head positive, all right? Pi over 12. I don't know, pi over 12, we get 1.12, and then pi over 6, 1.19, and then pi over 4, we get 1.20, and then pi over 3 starts decreasing, we get 1.009. That's a steep increase. Okay. And then finally for 5 pi over 12, get 0.82. And then for pi over 2, we'll get 0. So, okay, it's a gradual increase and then it suddenly decreases. So it's like this and then like that. This is for the first part of the curve. Now let's do it for the second part. So supposed to draw a smooth curve from theta equals to 0. So let's do the negative parts. So negative pi over 12, you get 0.314, and then negative pi over 3, get 0.459, and then negative pi over 4. Just to be safe, do as many values. Okay, you get 0.590, and for minus pi over 6, you get, let's see, over 6, you get 0. Oh, it starts, okay, it's still increasing, 0.725, and then finally for negative pi over 12, okay, you'll get 0.864. Okay, so as you can see, this increases more gradually, so it's something like this. Yeah. So This is our final answer for this part. Let's head on to the final part. Okay. So now we're going to have to find the area of the region bounded by C, giving your answer in exact form. So to find the area bounded by polar curve, you have to use this formula, half the integral of r squared with respect to theta, and then your limits would be the values of theta, which it surrounds. So in this case, we're surrounded by both pi over 2 and until negative pi over 2. All right, first of all, let's plug in our integral. So r squared is just e sine theta, sine theta, cosine theta, d theta. Okay, so to integrate this, we are going to use integration by substitution. So we can substitute u equals to sine theta, and then we'll get du is cosine theta d theta. And now let's also change our limits. So our upper limit would be sine pi over 2. Okay, so this is 1. And the lower limit would be sine negative pi over 2, which is minus 1. So this is half limit of, 1 minus 1. Then this is e to the power of u, du. Okay, now we can easily integrate this, So this is e to the power of u, then the limit is 1 and minus 1. So this is half times e to the power of 1, which is e, minus e to the power of negative 1. Hence our answer is half e minus half e to the power of negative 1, or half 1 over 2 e. So n units squared. So this is our final answer for this part. And if you want to check whether integration is correct, you can just type this exact integral into your calculator. So we have finally come to the end of this paper. So I hope you found this video helpful. If you did, please make sure to like and subscribe to this channel and share this video with anyone who might find this video helpful. If you have any questions or doubts regarding the questions in this video, or any future video ideas, or what paper you want me to solve next, feel free to leave them down in the comments below, and I'll see you again next time. Okay, thank you.